Hello and welcome to the first day of Virtual Math Club. Remember that this is all going to be online. So the way we're going to work on this is I'm going to post the videos, and next to it I'll also post the sheet that I'm working on. So just like in Math Club, you would get these sheets and you would essentially work at your own pace and do whatever you need to do. I will be solving the problems. What I'll ask you a lot of times to do is to pause the video, try out the problem, and then when you're done, you can essentially you can watch it. The reason I want to do that is so that way I'm not just like awkwardly sitting here and having a bunch of dead time. So be ready to pause and try this warm up. So pause the video now. When you're done, come back. Okay, another thing I want to remind you is that you can always fast forward. So if you're like, hey, I just want to see the answer, I don't need the explanation, just fast forward to the end. Okay. All right, so we are doing average rate of change. Rate of change means that we care about units as well. Remember, that's a little bit different from slope because in slope, we don't actually care about the units. Here, we want to make sure we do that. So we are given two quantities. It says after 2 hours, he's at an altitude of 400 feet. After 6 hours, he's an altitude of 700 feet. So we need to determine which one is our x value and which one's our y value. So hours or time is always going to be our x. So in this case, we're going to consider it time, comma, feet. That's how we're going to set these points up. So I'll have 2 hours and 400 feet. And then we're going to say at 6 hours, he's at 700 feet. So if we're finding rate of change, remember we're doing slope. And slope is delta y over delta x. If we don't remember what that is, just remember that it's change of y values over change of x values. Now remember what I'm going to be doing here is I have to line up these points. So when I'm looking at these points, right, I'm looking at this pair here, this has to line up vertically when I'm doing slope. I can't just like say do 700 first for the y value and then 2 first for the x value. That wouldn't work out. But we subtract here and we get 300 over 4, which really means 300 feet over 4 hours. And we want to simplify that down. So I know I can make this down to 75 feet per hour. So this is 75 feet per hour. And that is our final answer here. That's the rate of change for our first one. Okay, for our next one, what we're going to do is we are saying a scuba diver is 700 feet below the surface. Oh, that's supposed to write. Hold on. 700 feet below the surface. Below means that we're actually dealing with a negative height, meaning that this first point, which may have tripped some of you up, should be 10 comma negative 30. Remember, we're still doing seconds comma feet as our units. And then the next one, 40 comma 100. But it's got to be a negative 100 because we're still below the surface of the water. So now I'm going to do slope again, right? The only difference between slope and rate of change is our units. So I'll do negative 30 minus a negative 100 over 10 minus 40. Now I picked the first point here instead of the second point because I just want to show you that you can use either or. I also want to highlight the fact that we're subtracting a negative here, and this means that we're actually going to be adding the numbers. If you're someone who's struggling with negatives, now is a great time to get that extra practice and feel confident with it. You can really run through Khan Academy or anything like that to help yourself out and feel really good with negatives because you're going to use subtracting negatives, multiplying negatives, raising negatives to power throughout your whole math. So this is 70 over negative 30, meaning that we can simplify this down to negative 7/3 feet per second. Negative 7/3 feet per second. And that's our final answer. Okay, so that's roughly each second we're going down roughly negative 2 1/3 foot. So not too bad. All right, so let's go back to graphing in slope-intercept form. Remember that slope is the m, and that tells us how much we're going to move up and down. And then b is our y-intercept. That's kind of our starting point. Intercept. And this is something we've done a little bit with, so I understand if you feel pretty comfortable with it, but humor me and let's just review it. So remember that if slope is positive, this means positive, then you're essentially going to be moving up and to the right, or you're going to be moving down and left. Down and left because down and left are negatives, so they will cancel each other out. If you're looking at a graph and you're going left to right, that means that your graph should be going up. If your slope is positive, you should always have your graph going up. Now, if the slope is negative, then the opposite's going to happen. We need one of them to be negative. So if the slope is negative, then we're going to have what ends up happening is we can either go up and left or down and right. Essentially, as we move from left to right, we should see that our line is going down. So think about it, if you were starting somewhere, are you going up the hill, meaning that it's a positive slope, or are you going down the hill? That's going to be our negative slope. Okay, so keep that in mind when we're graphing these lines. So we're going to start by finding the equation, and then we're going to graph it. If you feel like you already know how to do this, and you want to try it out on your own, you go for it. But I'm going to walk us through step by step. So if you want to just get the end, then this is where you pause. If not, then keep watching. So the first thing I'm going to do is I'm going to take these 2 points, and I'm going to find the slope. Okay, so our first point is figuring out which point that you actually want to use. So I'm going to use this point first because it has bigger x and y values, so I know I'll be dealing with less negatives. If you use 2, 2, it'll also work, but it's up to you however you want to do it. So I like to start off with 6 over 8, so that way I know I've lined up my y's over my x's. Again, remember slope is delta y over delta x, or rise over run. And so it's this y value minus my other y value over my x value of that same point minus my other x value. So that gives me 6 over 4, which simplifies down to 3 over 2. And remember, we want to keep this as an improper fraction because this will help us with our rise over run. So now that we know that we have our slope as 3 halves, I'm going to write this as y equals 3 halves x plus b. And then what we're going to do is we need to figure out what b is, right? We know what our slope is, but we don't actually know what b is. So we don't know where to start this graph, right? Because we could technically get an infinite number of lines with the slope of 3 halves, but only one is going to fit these exact 2 points. It's one of the essentially axioms or ground rules for math. Between 2 points lies exactly one line. So we can create this equation. So I know y equals 3 halves x plus b. And I'm going to pick one point to plug in and figure out what our b value is going to be. So I take this point, let's use 2, 2. So 2 goes in the y. 3 halves times 2 plus b. So now I simplify this down and get 2 equals 3 plus b. And now because 3 and b are put together through addition, I'm going to subtract 3 from both sides. So that way I get b by itself. And b is -1. But we can't stop here, right? We can't just say, oh, b is -1, I'm done. We need to actually plug that back into our equation. So we plug that back in, and we get y equals 3 halves x minus 1. So this means we're going to start with -1. We're going to start with a y-intercept of -1. So I'm going to go down 1 on my y-axis. And now I'm going to use my slope of 3 halves. So because it's 3 halves, remember that's rise over run. I'm going to go up 3 units and then to the right 2 units. And if I want to, I can continue doing that, right? I can keep going up 3 and right 2. Or here's this other piece I can do. I can start here and I can go down 3. That's a little bit more than 3. I can go down 3 and then left 2 And so what this means is essentially we know our line has to go forever and ever, right? So by doing down 3, that's a -3, and going down 2, that's a -2. But that slope simplifies down to 3 over 2, so we know we're okay. So now my last step that I want to do is I'm going to connect all my points. The reason we connect our points is because these are the only points that we found with nice, essentially what are called lattice points. They're points that fit perfectly on a line. They're all integers, right? But we know that every point in between these points that we have is also a solution. So if I wanted to, I could figure out where some other points are, right? And my graph doesn't hit everything perfectly, and that's okay, right? Our goal is essentially to be able to sketch this and graph some points. So here's my equation, and here is my graph. Okay, let's move on to another one. So this would be a great time for you to pause the video, come back and see where you went wrong or where you got it right, and then you can move on. Pause the video now, and I'll do the problem. Okay, so this one's a little bit more tricky because I'm going to be dealing with these negatives. Again, it doesn't matter which point you use, so I'm going to start with this point first just to show you that we can do either point when we're trying to solve these problems. So -6 over 3, again, that's just me lining up my x and my y values. Remember, we still need to subtract our other x value, our other y and x values. So here's my x, here's my y. I'm going to subtract a -10. And then I'm going to subtract a 9. And so -6 minus a -10, that minus minus becomes a plus. So this becomes a +4. On the bottom, this becomes a -6. So we want to simplify this down, right? Because we aren't comfortable with leaving 4 over -6 as our final answer, right? We always want to simplify down. And so this gives us uh, our slope equals -2/3. Now notice I moved that negative sign up. That's okay. You can put the negative wherever you want because if you put the negative on the numerator or the denominator or out front, it's the same thing as that entire quantity times -1. So we're fine with that. So y equals -2/3 x plus b. Again, I start with this slope-intercept form and then figure out what b is afterwards. So to figure out what b is, I'm going to plug in either point. So y equals -2/3 x plus b. Let's plug in 9, -10 here. So -10 goes for the y value, and 9 goes for the x value. Oops, sorry about that, guys. And then we put plus b. All right, so what we're going to do next is simplify this down. And so that would become a -6 plus b is equal to -10. So I'll add 6 to both sides, which leaves me with b is -4. So y equals -2/3 x minus 4. So this time we still have that negative y-intercept of -4. But now what we're going to do is we're going to go down 2 to the right 3, down 2 to the right 3. We could also, because it's -2 over 3, that's the exact same as 2 over -3. So I could go up 2, which is what that +2 in the numerator means, and then left 3 as well. And I'm just going to do a couple points just so that way we kind of get a feel of this. And then we connect them. And again, we always want to put arrows at the end. The reason we want to put arrows at the end is because our line is infinite. This isn't the only thing that we're going to be doing, right? These aren't the only points. It keeps going on forever, right? And so that's important for us to know. Okay, so our final equation is this, and here's our final line. Again, I don't, if you're actually answering this, don't box your line. I was just doing that so that way you guys could quickly see it if you were fast forwarding the video. All right, here's 3 problems for you to try out. Again, pause and come back to this. I will be doing these one at a time. Okay, so for our first one, what we're going to do is we're going to take this point first. Oh, there we go. and we're going to do our delta y over delta x. So I'm going to line those up first, and then subtract 3, and then subtract 2. Remember that -7 minus 3 is actually going to come more negative because of the same sign. It's essentially saying you went left 7 from the number line, and then you went left another 3. So now you went left a total of 10. So this becomes -10 over 2, which simplifies down to -5. So far my equation is y equals -5x. That's a negative. There we go. Plus b. All right. Now I will plug in a point. Let's say we want to plug in this one. Why not? And so we'll get -7 equals -5 times 4 plus b. And so -20 plus b is equal to -7. And that's going to give us a very high number. This number will actually be a little bit off our graph, and that's okay. We'll work with that, right? So we get y equals -5x plus 13. Now, some of you may like to just simply essentially take this and make 3 more dashes above the line. 1, 2, 3, and then start there. I can't make a third dash. What I'm going to do instead is say, okay, I know I start at the point 0, comma 13, right? That's my y-intercept. My slope is -5, so we're going to write that as -5 over 1, meaning that from there I would go right 1. So I'm going to increase my x value by 1, and I'll also decrease my y value by 5. So I know I can plot the point 1, comma 8. So I'll actually plot that point 2, 4, 6, 8. And then from there, I can keep going. So I'll go down 5 and then right 1. So I can get the point 2, comma 3. And then I'll do this just a couple more times. So I'll go 3, comma -2. And I think that should be enough. And again, this is not something you have to do, but this may help some of you who are struggling with trying to plot those points, right? Treat the slope, essentially, this is how much you go change your y and then change your x. So I knew because the y was -5, I'm going to take each point and go down 5. And then for my x's, I'm going to increase by 1. So I'm going to graph this line. Oh no, look how curved that is at the end. That's okay. It's just a sketch. But here's our equation. Here's our, let me do that box again. Here's our equation, and here's our line. All right, next one. I'm going to find the slope once again. Crazy, I know. I'll do this one first. So we just deal with all the negatives. So it'll be 5 over 3 minus 7 and then minus 6 on the bottom. Again, I'm doing this so that way my x's and my y's line up perfectly. And so on top, I end up with a -2. On the bottom, I end up with a -3. So because I have -2 over 3, I need to rewrite that as +2 over +3, because our negatives will cancel out when we're dividing, just like how they will cancel out when we multiply, right? A negative times a negative is a positive, a negative dividing a negative is a positive. So y equals 2/3 x plus b. Oh, that's a circle. I don't want that. Okay. So we're going to go again, and now we're going to plug in our value for b. Let's say I plug in, let's do this point. Really easy with a 2/3 times 3, right? Don't even have to worry about doing anything other than canceling out the denominator. So I multiply these together. 2/3 times 3 would be 6/3, which simplifies down to just 2. And so now I know b is 3. So let's try to write this in a different color and graph it in a different color so we know we'll be okay with it. Okay, so I'll write this in red. That's still purple. I would like red. Y equals 2/3 x plus 3. And so now I'm going to start at +3. And now I'll use that slope of 2/3. So I'm going to go up 2 to the right 3, up 2 to the right 3, or I can go down 2 and to the left 3. down to the left 3. And so I connect all of that, and that's my line. So the red line goes with the red equation, the purple line goes with the purple box equation. All right, final one. We get here and we say, let's use, we got a lot of negatives. So let's use this one first again. So 2 minus a negative 6. I know I'm changing it up on you, but I'm showing you multiple ways you can do this. And then 5 minus a negative 15. So on the top, the 2 minus a negative 6 means it's really 2 plus 6. So that'll give us 8. And on the bottom, 5 minus a negative 15 is 5 plus 15, which is 20. So what we're going to do is we're going to divide, well, we'll simplify that down, and that simplifies down to, what can we take out? Well, what's the greatest common factor of 8 and 20? That's going to be 4. So we'll say this is 2 over 5. So we have a slope of 2/5. So y equals 2/5. Y equals 2/5 x plus b. We plug our point in, and now we have, let's say y equals 2/5 x plus b. Let's plug our point in, and we'll get 2 equals 2/5 times 5 plus b. Got to erase more over here. So now we get 2 equals 2 plus b. That tells us that b has to be 0. We subtract 2 from both sides. So we have what's called a direct variation equation. Now, you don't need to know what that means, but essentially it's just telling us that this slope has a direct variation, meaning that if you take an x in, you can plug it and you'll get a specific y. There's no y-intercept whatsoever. So the big thing you want to take away from all of that is that a direct variation has no y-intercept. So we're going to start at 0. I guess I shouldn't say no. I should just say that the y-intercept is 0, right? So we're going to take 0, 0, the origin, as our y-intercept, and now we'll go up to the right 5. We could also go down 2 and to the left 5. 2, 4, 5. Again, I could keep going if I want, but it's not really necessary. Once you get a couple points, we're okay. And there you go. Those are our 3 equations, graphed and written. So hopefully we got those all right. If not, go through and recheck what I did. If I have any mistakes or anything like that, please let me know. Send me an email or leave a comment, whatever you want to do. All right, final 2 problems. Now we're going to be looking at a graph where our equation isn't in slope-intercept form. So there's 2 different ways that we could go about doing this. One of the ways we've already done, and this was where we would solve for y and get it in slope-intercept form. That's probably the way you guys are most comfortable with this, but I'm going to show you both and you decide which way you want to do it. So first, let's start with the way you already know. That's when we did literal equations and we said, hey, we can solve for y here. We're going to subtract 2x from both sides because we're allowed to do that. That's fine. 2x and 3y are put together with addition, and because 2x is positive, we're going to subtract 2x from both sides, so that way that'll give us a quantity of 0. And then we're going to divide everything by 3. Every single term. You don't get to pick and choose. You have to divide everything by 3. So our final answer is y equals negative 2/3 x plus 5. So this tells us that we'll get a y-intercept of 5. And now we're going to use our slope. Again, we have a negative slope here, so we're going to go down 2 to the right 3, down 2 to the right 3, or we could go up 2 and left 3, up 2, left 3. Either one of those will work, but we want to kind of do it in both directions so we get the entire picture of the line. We don't want to just do one. So here's one way to do this, right? All right, let me show you another way. And this way you might not like as much, but we'll look at it. Okay, so this is an equation called standard form, or it's in standard form. So we're going to call this standard form. Standard form says we want all of our x's and y's on the same side. It's going to have ax plus by equals c. And I know you might be saying, Mr. Erb, that's too many variables. What are you doing? I'm okay with 2, maybe 3 if on a crazy day, but 5? Ridiculous. All right, so we have a couple rules with this one. Essentially what it tells us is that a and b are going to be positive, and usually, or sorry, a and b are going to be integers, and usually a is going to be positive. This just helps us when we're solving it. If we're all keeping it the same form, this is why we call it standard form. Okay, so what we know about standard form and this particular equation is it's really helpful for us to find our x and y intercepts. X-intercept, we know we're going to have some number, comma 0. What that tells us is that the y value is 0, meaning that it's flat on this x-axis. It's flat on this, right? Whereas our y-intercept, we're much more comfortable with finding it's 0, comma some number, right? We've seen that quite a bit. We've seen that anytime we graph. But that tells us it's on this vertical axis. So what we're going to do is we are going to plug 0 in for our x value to find the y-intercept. We'll plug 0 in for our y value to find the x-intercept. So let's start by finding our y-intercept. I'll switch colors for this. So we're going to go 2 times 0 plus 3y equals 15. Well, this becomes 0, so 3y equals 15, meaning that y is 5. So we know our y-intercept should be 0, comma 5. So 2, 3, 5. Hey, that's the same point we already graphed. Okay, so now we have our y-intercept. Let's do the exact same thing with our x-intercept. So for our x-intercept, see, just tricky, just change that to an x, right? Now I'm going to plug 0 in for y, and that gives me 2x plus 0 equals 15, or 2x equals 15, which means x is 15 halves, or 7.5. Let's see, 2, 4, 6, 7. So 7.5 is going to happen somewhere right in between 7 and 8, which is good. So this will give us the exact same line, which is great, because if it didn't, we did something wrong. But again, these are two different ways we can write this, right? We can either find the x and y intercepts in graph, which is kind of the quick way, but if you want, you can always just put it into slope-intercept form and also graph that. Either or, it's up to you. That's the great thing about mathematics. There's so many ways you can do a problem. Try it out. So pause the video here and go for it. Okay, so I will first do it the way you're most comfortable with, which is by putting this in slope-intercept form, and then we will also try finding the x and y intercepts. So 3x is going to get subtracted from both sides. And now here's the where we really want to be careful. This is a negative 4y. That sign still stays. Negative 4y equals 3x plus 16. So now we divide by negative 4, divide by negative 4, and now y equals a positive 3/4 x minus 4. A positive 3/4 x minus 4. Because remember, 16 divided by negative 4 is going to give us that negative 4. Okay, so we start off by graphing with our y-intercept. So down here at negative 4. And then from there, we'll use our slope of 3/4. So we're going to go up 3 to the right 4, up 3 to the right 4, or also down 3 to the left 4. And we connect. And there you go. Let's do it the other way. So let's find our x-intercept and our y-intercept. So to find our x-intercept, we're going to plug 0 in for y. So 3x plus 4 times 0, that's an x, equals 16. So 3x equals 16, or x is 16 over 3. So 16 over 3 is roughly going to be 5 and some change, right? So we go 2, 4, 5, 5 and a third, right about there. Now we do the exact same thing for our y-intercept. We're going to plug it in. And that'll give us 3 times 0 minus 4 times, 4 times y equals 16. So negative 4y equals 16, or y is negative 4. And hey, that gets us, again, the same line. Okay, so again, 2 ways you can solve it. Up to you, however you want to do it. All right, so what we want to think about going into the next lesson is, what does it mean if we have a system of equations? What does the system mean? What does it mean to have a solution? So if you guys have any questions, please feel free to reach out. Make sure you're doing that extra practice, right? So this is just a video of me explaining. You always want to do that extra practice as well and see, make sure you feel comfortable with it. If you have any questions on any of the extra practice, any of these problems, you can either leave a comment or you can also just send me an email. If you don't know my email, it's Tyler, there we go, 1.erb, that's my last name, at cms.k12.nc.us. And I will answer either one of those. Okay? So if you have any questions, please feel free to reach out. But otherwise, good job. Way to watch the video. You're getting better at math. That's always our goal, no matter what. So have a great day. Bye-bye.